All right, everybody, welcome to Math with Grace.
Hello, in today's video we're going to be discussing more constructions, including the construction of triangles. We're working in Geometry Book 1007 from pages 21 to 43.
Our first construction for today is construction 10, and it is on page 21. And what we're doing here is we're constructing a line parallel to a given line through a point not on that line. Now, just like last time when we were doing constructions, you want to make sure you have your compass handy and your handy dandy ruler, and you're all set to go. Our first step in making this construction is drawing a transversal. Okay, we all remember what a transversal is, right? So it can be at any angle, let's say, that you choose, but you want it to be something useful, something you can work with, okay? But we're going to draw a transversal through line P or through point P, and line L. So we're just going to choose a decent angle here and draw our transversal, okay? There we have it. Step one, okay? Our next step is going to be to copy the angle that we've created with our given line. Okay, so to do that, we're going to make our compass just a nice working size. Okay, with our pin at the vertex here, we're going to just draw our arc. All right, now without changing our compass, we're going to move up here. Sorry about that. And put our pin at point P. All right. And then just make a slightly larger arc, since we're not exactly how big it is. We're not sure exactly how large it is at this point. So we're going to make sure we have enough arc there to work with. All right. Then just like before, we're going to take our compass and measure the length of our arc. Now, instead of starting at the line, because we don't have a line up here to go off of, I'm starting at my transversal. So I'm going to put my pin where our arc met our transversal, and then I'm going to extend my, try not to have a shadow, compass, okay, until I reach our starting line, intersection point, all right? Then, without changing our compass, we come up and we make the exact same intersection on our arc that we drew up there, okay? This is our point of intersection here. Now feel free to turn your paper if you want, but this is the point that we're going to go through with our P. So we're going to line up neatly with our intersection and our P and draw a line that is now parallel to line L. Here in geometry, we don't need to worry about things being exact. For those of perfectionists out there, don't freak out if it's not exact. You're students, you're learning. We're not building bridges or buildings here today, okay? In this classroom, grenades are good enough, okay? So we want to be close. That looks like a very good parallel. Let's do another one, except this time we have 2 points off the line. So rather than just drawing a transversal wherever we want, we're going to draw our transversal through these 2 points. Note to self, this is problem 162, okay? So I'm going to make my transversal through A and B, all right? And of course, just like the problem 161, the example we just did, we've created an angle here at our given work line, okay? That's the angle we're going to use to construct our parallels. So, comfortable working size for your compass, okay? You're going to start with your vertex point here at line L and your transversal, and you're going to make your arc. All right, now, again, without changing your compass, come up here to point A and make a fairly good size arc, okay? And then also come down here to point B and make another good size arc, okay? We're on the right track. Now, Again, we're going to measure our arc, our original arc here, from the transversal to the line. So with my pin on the transversal intersection of the arc, I'm going to adjust my compass so that I am at the intersection where it hits the beginning line, okay, our original line. Then using that measurement, I'm going to come up here to this arc on the transversal with my pin and measure how long it needs to be here. Same exact thing, not changing it. I'm going to come down here where this arc meets the transversal, and I'm going to mark where they intersect. All right, so now I've used this length to mark both of my other working arcs, okay? With that done, we have our parallel lines intersections. So we start at A, crossing through that point, and we have a line parallel. Go down to B, make sure you're hitting that spot. I missed it a little bit. Okay. And now we have 3 parallel lines, and we can say that A and B are parallel to each other because they are both parallel to line L. 2 lines parallel to the same line are parallel to each other, right? And that is the construction of parallels. Okay, so construction 11 is a little bit different. We're given a segment and they want us to divide it into equal parts, okay? So how we begin doing that is we find our ruler and we're just going to draw a ray at a comfortable angle to our line. Okay? Boom. We're just going to draw a ray from point A at a comfortable angle. All right, that's step 1. The next step is using our compass, we're going to find a workable radius, they're calling it, basically this distance here. And we're going to start with our pin at point A, and we're going to make a mark here for the number of divisions that we want. And let me check because I forgot to write it down. We want 3 equal parts, okay? So we're going to start and we're going to make one mark here, okay? This is a new point on our array. Without changing our compass, we're going to now put the pin at that new radius or new point, and we're going to make another one. All right. Then we're going to do this one last time because we want 3 equal parts. Okay, so I've made 3 points equidistant from each other, okay? And there's our 3 points. 1, 2, 3. All right. Now, because we only want 3 points, technically this is our last point that we need. So we're going to connect it with point B up here. Okay, we're going to connect it with point B. Now we've got an enclosed triangle, correct? All right, with that now, we can come back and basically what we're going to do from each of these points, the last 2 points here, is we're going to create a parallel to this point, to this line. We need to create 2 more lines here that are parallel to this XB, okay? So just like before when we were doing parallels, except this is quite a bit smaller area here, we need to make a little arc this time, but it needs to be measurable. So let's see, that'll do. Okay, it's not quite the length of the thing, you know, the in between, but just slightly less than. So starting at my point X that I created, I'm going to put my compass and draw an arc. All right, now without changing my compass, I'm going to go up to each of my other points that we created and draw arcs just slightly larger than the arc that I drew. And yes, this one's going to cross, it's okay. All right, there's my arc. Now, I'm going to come back and I'm going to put my pin now on my ray and measure the length of my arc. Okay, so with my pin on the ray, I want to measure my arc. If I can get it, there we go, okay? It's in the shadow, I apologize. So I measured my arc, okay? Here is how long my arc needs to be. Now, at each of these points, I'm going to come to my ray and put my pin in and mark each of my arcs, okay? So I did that for the middle one. Here's the top one, okay? There's a measurement now in each of my arcs. So I can take my ruler at this point from the point on the ray through the intersection here, okay? And then I want it to intersect AB, which was our original line. Now this one just happens to be pretty much right on it already, okay? And if we put points at those, we now have AB divided into 3 equal parts, okay? These constructions can get a bit messy, but that's the basic steps you take to do it. Let's do one more here. We've got section CD, segment CD, okay? Just like before, we're going to make a ray. Okay, coming down. For this one, because I forgot to write it down, we need 5 equal parts, okay? This one, they want 5 equal parts. So we're going to take our compass, again, at a workable size for 5 parts, okay? And we're going to mark our 5 segments down our ray. Okay, here's 1, 2, 3, 4, 5. Time out for a compass repair. All right, so I've marked my 5 spots. I'm just going to go ahead and actually fill them in with a dot. So because, you know, it's a little bit messy, I like to know exactly where my points are and not just have a little check mark there, okay? All right, 1, 2, 3, 4, 5 points. Just like before, we're going to go to the very last point and connect it with the last point in our segment, okay, our original segment. Now from here, we can make our parallels. So first things first is we need an angle. So I need it to be slightly smaller than the original radiuses that we made. And we're going to make an arc, okay? And again, without changing our compass, we're going to go to each point and create an arc. Each point and create an arc. Okay, this is going to help us create our parallel lines. Okay, now with our point, okay, on the ray, we're going to measure our arc. Okay, so I'm going to put my point on A, or on the ray, I'm sorry, and measure my arc. It's a little short one, okay? Now, at each of the arcs that we made for the other points, we're going to go ahead and put this measurement. So always with our pin on the ray, we mark the intersection point. Pin on the ray, mark our intersection. Pin on the ray, mark our intersection, and again, pin on the ray, mark our intersection, okay? Now we've successfully constructed parallels, so we just need to basically connect the dots. So I'm going to start at the bottommost point, going through the X, and boom. Next one up, through the intersection, boom. Okay, next one up, through the intersection, boom. And final one, through the intersection, which again, just happens to kind of fall on the line already. Boom. All right. We've successfully broken CD into 5 equal parts. Okay. And that is construction 11, which is dividing segments. Okay. So moving forward to construction 12, it's kind of an interesting one. They want us with the given segments, okay, to find the fourth proportional to the 3 given parts that we have here, okay? We've talked about fourth proportionals before. Now we're creating them, okay? Well, the first step to do that is just to make an angle, okay? And most of these, the example in the book kind of looks like an A, so most of the ones that I did ended up looking like an A, so that's where I'm going today. All right, so we're just creating an angle. Okay, my vertex is up here, and it's going to be whatever, a workable angle. Okay, boom. This is our work angle. Okay, the next step will be measuring our parts. Okay, we have segments A, B, and C, and we are looking for the fourth proportional when we're going to label it X. Okay, so first things first, we're going to measure A. So pin in, measure the length of A. Okay, and then I'm going to put this on my work angle here. I'm going to turn my page a bit. Starting at my vertex, I'm going to mark where A should be. Okay, and this is segment A. All right, feel free to label your angle with letters. I don't know how necessary that is, so I don't really do it. But I know the example in the book labels everything, but they use redundant labels, and so it can be kind of confusing. So if you're going to label it, don't use any of the letters A, B, and C, because to me that gets confusing. Okay? And I don't want you guys to be confused. So I'm not going to label mine. We'll just work through it together. Okay? All right, with that being done, okay, we've got A. Now we're going to measure B. So with my pin and one side of B, I'm going to stretch it out here and measure B. Now, instead of starting at the vertex, we're actually going to add B onto A. Okay, so I'm going to start with my pin at the point here that I made for the length of A, and I'm going to mark B. So now we have A and B on the same side. They're on the same ray of this angle, okay? So now we can come over here and measure point C. So I'll get my pin in, or segment C, I'm sorry, and we measure it. Now, this one we're going to put on the other side, all right? So starting at the vertex of the angle again, we're going to mark C on the other ray of this angle. Oh, and I forgot to label my B and C. Okay, so now we have the three parts we were given. We're looking to see what this fourth proportional is going to be over here that goes along with part C, with segment C. Okay, we don't know what it is yet though, so we can't mark anything. But where we go next is we are going to connect the lengths of A and C here. Okay, we're going to connect this line that would be between these two. All right. So I'm going to make it a little bit larger, but there we go. Okay, we connect those 2 points. Now we have the connection between A and C. All right, so basically what we're looking to do now is construct a parallel to AC at point B. All right, and just like constructing any other parallel, we're going to use our compass and do it. All right, so segment A was pretty short, so we're going to need a pretty tight angle here as our starting angle. Okay, that just about does it. So at point A, crossing this ray, sorry, my hand is in the way, rhyming today. Okay, so we've made our arc. Okay, so now without changing our compass, we're going to come down here to point B, and we're going to make an exact copy of our arc, just like always. Okay, parallels. We just did it a few minutes ago. Okay, now starting with our ray, with our pin in our ray, we're going to measure this arc now. Okay, so we need to know how long this arc is. It's a little bit longer. Here we go. Okay, so it's about that length. So then I'm going to move my pin down to this new arc that we drew, still on the ray, and mark its intersection. Okay, we now have enough to draw a parallel line to AC through point B. Okay, and we want it to intersect the other ray on the other side. Okay, so it intersects at this point, but really what we're concerned with is this segment. This segment is our X. Okay, this segment is our fourth proportional. All right, let's try it one more time. So again, we have 3 segments, okay? And we're going to start with just an angle. I'm going to try making this one a little wider. Let's see what that does for us here, okay? Here's our angle, our work angle that we're going to use, all right? We have R, S, and T, and we need to find the 4th proportional. So, just like before, we're going to start by measuring our R. Okay, we put our pin on R, one side of R, and we measure it. And then we transfer that over, starting at the vertex of our angle, and we make our line, or our intersection, which becomes our point, and we label that R. So then the next step will be to measure S. So putting our pin at S, we're going to bring it down here and measure our S. All right, and then again, we're going to, without changing our compass, we're going to transfer that and basically adding it to our R. All right, and this is segment S. All right, 1 segment to go. So we're going to come over here, put our pin at T, and measure the length of our T. All right, we're going to starting at the vertex now because we want T on this other ray of our angle. We mark the length of T, segment T. All right, now we know that our 4th proportional X is going to be over here somewhere, but we've got to figure out where that is. To do that, again, we're going to connect the endpoints of R and T, okay? And then we're going to construct a line parallel to those at point S. Now, S was very short, so obviously any arc that we're going to make to construct this parallel is going to overlap. We're just going to have to work with it. It's going to be a little bit messy. Just try to keep focused on what exactly we're working with, okay? So I am going to make my arc small-ish, right? But either way, I can't make it that small and actually be usable, or smaller than that and be usable. So I'm just going to go with something I'm comfortable with, all right? And then it's about that. So starting at my end point for R here, I'm going to make, for Pete's sake, I'm going to make my arc, okay? I tore my paper, but that's all right. Okay, so I made my original arc. Now, without changing my compass, I'm going to come down to the end point of S and do the same thing. So our next step with any parallel is to measure our arc. So starting with our pin on the ray, we're going to measure our original arc, and it's a pretty small one, not to mention that my pencil's getting worn down a bit. Okay, now we're going to transfer our pin to the other arc that we drew, and we're going to use the same measurement without changing our compass to draw an intersection there. Okay, with that done, we can connect our line here through our X marks the spot, and we have our parallel line. Okay, and this segment created is our 4th proportion, or our X, and that is construction 12. All right, for construction 13, we will be constructing the geometric mean between 2 points that have been given to us. Okay, if you are hearing the word geometric mean and you think you've heard it for the first time, go back to book 105 or 1005, page 41, and please review what is a geometric mean. But if you're like, all right, geometric means, I gotcha, then let's do this, okay? What we're going to start with, we've got our 2 segments here, and what we're going to start with is our famous and wonderful work line, okay? So, of course, anywhere and whatever length you would like it to be. Here's our work line. I'm going to choose a point at the end to be one end point, and we'll start from there. And how we start from there is we'll start by measuring point A, or segment A, okay? So I'll put my pin here at the end of A and measure out the length of A and add it down here. Now again, if you would like to label your points and not just your segments, please feel free to do that. My suggestion is to use letters that aren't an A or a B, because it just gets a bit cluttered at that point. All right. But now we're going to go ahead and measure B. So pin in at B and got our measurement for B. We're going to add that to our measurement of A. So I'm going to go to the other endpoint of A and mark off where a B would be. So now on our work line, we have A plus B segments, okay? And that's our first step. All right, so then the next step is to find the midpoint of our AB segments, okay? It's not going to be this funky big old point I put here where they connect, but it's going to be some other point. Now, we did midpoints before, so let's do it again. Just in a midpoint, we want our compass to be slightly larger than what our midpoint would be, right? It can be, looks like a good length. And then starting at one endpoint or the other, I'm going to start over on this side. We're going to put an arc. I think it needs to be a bit bigger. Okay, we're going to put an arc at the top and a small arc at the bottom. Okay, then without changing your compass, you're going to switch over to whichever other side you haven't done yet and put an arc at the top and an arc at the bottom. Okay, you can see where our arcs have intersected, creating two X's. Perfect. If we line up our ruler with those two X's, okay, I'm not going to draw a full line because for this construction that will be in the way. I'm just going to draw a line on my segment. Okay, that is my midpoint. It's fabulous. Good job, everybody. All right, so now we have our midpoint of our two segments AB. Using that midpoint, okay, we're going to construct a semicircle. So I'm going to put my pin at the midpoint and then bring my compass in till it's at the end point, the beginning point of A. Okay, this is going to be our radius for our semicircle. So using that, we're going to come around here and it should hit your end point over here for part B. So we've done a proper semicircle, right? Very good. All right, with that being done, now we need to go to the point where A and B intersected here, and we need to construct a perpendicular. All right, we've done those before as well. Look back if you need to. Okay, but to do a perpendicular, we're going to shrink our compass down here because we want our dog ears, right? So we're going to start at our intersection of AB. I'm going to dog ear one side, and without changing my compass, I'm going to just swivel it around and dog ear the other side. Okay, those are my two work points now to create my perpendicular. All right, so now I'm just going to extend my compass to a nice working length and make two more small arcs. I'm going to go up here. You can do them from the bottom, it doesn't matter. So I'm going to make one from that dog ear on that side. Without changing my compass, I'm going to move over to the other dog ear and make another one. All right. Now, if I connect my intersection point of AB here with that X, that will be my perpendicular line. Okay. And I want to make sure I cross my semicircle line. All right, so here's my perpendicular line. The segment here from the semicircle to our line, our work line, is the geometric, and you know how terrible I am at that shape. Okay, is our geometric mean between A and B. And that's how we do a geometric mean. Let's do another example. For the next example, we have our sections R and S. But we're going to start off the same way. We're going to start off with our work line and designating a point to begin our drawing, okay? To begin our construction. With our compass, we're going to measure the length of R, and it's just a wee little segment here. Okay, it's about that long. we're going to mark it. Okay. Then we're going to add to that segment S. All right, so starting at that endpoint we created for R in my shadow here, I apologize. Okay. We create segment S. So now we have them together on our work line. So just like before, first step, find the midpoint. Okay. So with a compass measurement larger than what the midpoint would be, we're going to start on one end of our joint segments here and make an arc at the top and the bottom. Without changing our compass, we're going to switch over to our other endpoint and mark there. As you can see, my marks didn't quite cross all the way here, so I'm just going to double check and make sure I have the right one. And so I just added a little bit to it because I didn't change my compass. It was easy. Okay, again, you can see why I didn't want to draw the midpoint line all the way across. I just wanted a small segment. So I'm going to do the same thing here. I'm going to line up my ruler and I'm just going to mark my midpoint with a line, not a full line across the drawing, just a line. All right. So now that we have our midpoint, we can put our pin there and make our radius equal to the outer edge and draw our semicircle. Okay. Okay, very nice. All right, we've got our semicircle now, the full width of our segment for the diameter. Looks great. Okay, again, now we're going to be working with this intersection point here between R and S. This is our point that we want to work with. This is our point where we want to create our perpendicular. Now, our section R was quite small, so our dog ears are going to have to be pretty small to fit inside there. I really need to get a new lead for my compass, but I'm going to put a dog ear on one side, turning my compass, and a dog ear on the other side. Okay, these are our work points now to create our perpendicular. So we can extend our compass nice and big, working outside of our semicircle at this point. And I'm going to start at the dog ear on the right and make an arc somewhere out there. Okay, then without changing my compass, I'm switching over to the dog ear on the left, and we've got our intersection. Okay, using this intersection with our connection point, or our point together there where R and S meet, we can draw our perpendicular line. All right, this segment from the semicircle to our work line is our X, is our geometric mean. All right, and that is construction 13. All right, the next thing we're going to be talking about are the constructions of triangles. Now, there are many construction of triangles that we're going to go over here in a rather quick pace, but they're not exactly complicated, so I think you guys can handle it. But they start on page 37 if you're following along. And the first one is constructing a triangle with 3 given segments. Okay, so I've got segment A, B, C, and they want you to make a triangle out of it. The first step to do this is to create a work line. We don't need a very large work line for this, but we need a work line nonetheless. All right, here's our work line. Here's the point that I'm going to start working at. All right, and then you can choose. It really doesn't matter which segment you want to go first, but we need to make sure we use all of the segments given. So I'm just going to start with A. So we're going to get our length of A. So with my pin at one side of A and my compass at the other, we're going to mark that on our work line. Okay, so here is our segment A. All right, now we're going to measure our next segment. For me, it's going to be segment B. Okay, from the left endpoint, or the right, whichever you choose to do, but from one endpoint of A, I'm going to put my pin, and just up there somewhere, I'm going to mark my length of B. Okay, so that's how long B is from that endpoint of A. All right, Then I'm going to take my compass and I'm going to measure C. And then I'm going to put my pin on the other endpoint. Okay, if I drew B, which I did, I drew B from the left endpoint. I'm going to draw C from the right endpoint. So I put my pin in there and I draw an arc, hopefully, that intersects B. Okay, now I have this vertice of our triangle. It's this intersection point up here. So I can take my pen and my pencil and my ruler and I can connect, oh my goodness, those, okay? And then that's segment B, if you remember. And then from the right endpoint, I can connect these and have segment C. So we've constructed a triangle. Mine's a little sloppy, sorry. But we've constructed a triangle from 3 given segments, all right? Well, the next triangle construction is from 2 given segments and an angle, all right? This one's very similar, but it has one slight difference, right? It's obviously we have an angle to work with instead of 3 segments. But just like the last one, we're going to start with our work line, okay? I've got my work line, I've got the point I want to begin at, and we start from there. At this point, we're going to measure one of our segments. I'm going to measure segment A. So I've got my pin at one end point of A, my compass at the other, and mark that on our work line. Here is our segment A. Now, instead of just marking B like we did in the last one, this time we're going to work with the angle as our next step. So with our pin at our vertex of our angle, we want to find a nice convenient arc, okay? And we're going to mark the arc on our given angle. And then without changing our compass and using an endpoint of A, we're going to mark that arc. I want to go quite a bit larger because we don't know exactly where it's going to fall. But we're going to mark the same arc on our work paper, okay, on our work line. Now, my work line is here, so I'm going to use this as the work line of the original arc, all right? So with my pin down here, I'm going to measure how large my arc is. So my arc is about that length, okay? Then transferring it down here at my work line is where I want to put my pin, okay? And then measure my arc. Okay, so now what we're about to draw is basically a work line number 2. So it's going to be larger than we need it to be. Okay, we have drawn a ray. Now to complete our triangle, we need to measure our segment B. Starting at one side of B, go out here and measure B. Now, we're going to put B, A is on our original work line, like work line 1. We're going to put B on work line 2. So, starting at the same vertex that we measured A from, but this time we're going to mark B on work line 2. Okay, so this segment here is segment B, that whole thing. Now, having these 2 endpoints here, we can connect them to get the final side of our triangle. All right, so now we've created a triangle with 2 segments and a given angle. All right, that's the another construction that we're working on for triangles. All right, the next triangle construction is creating a 30, 60, 90 triangle. So you guys should remember a 30, 60, 90 triangle means it's a right triangle with a 30-degree angle and a 60-degree angle. Okay, and our first step for this, just like our first step for the other ones, is going to be to draw a work line. Okay, let's get our work line going here. All right, and the point I'm going to begin at. Now for this one, I've given this example, I've given a segment. I'm pretty sure all the homework problems will give you the segment, but what we're going to construct here for our 30, 60, 90 triangle is an equilateral triangle. That's where we're going to start. An equilateral triangle is a triangle with all the sides equal. So just like we constructed a triangle here with 3 different segments. We're going to do the exact same thing, except this time we have one size segment, okay? Equilateral triangle. They're all the same length. So let's measure our length here. AB, okay? So first things first, we're going to put our AB on our work line. Okay, and then again, we're not changing our compass because we want AB for all the sides. We're going to make an arc from that end point of AB, and we're going to make a mark on that end point of AB, okay? Here's a vertex, and we're going to connect them. So now we have, to the best of our ability, an equilateral triangle, okay? The next step then is to bisect this upper angle, okay? We're going to bisect that angle. So let's put our compass at a nice, gentle, usable arc length, okay? And I'm going to turn my paper. With our compass at the vertex, we're going to make our angle go all the way across, okay? Now, using the intersections here with the triangle, we're going to create our bisection. So now I'm going to extend my compass nice and rather long, okay? And so with this intersection here on our triangle, I'm going to make an arc down below it. You can make it above, it doesn't matter, okay? And then I'm going to move my pin to the other intersection of the triangle and make another arc, all right? Now we have our X outside of our triangle. If we put our pencil at our vertex, and we draw a line connecting our 2 intersections here, we've now bisected this angle, okay? From there, we now have a 30, 60, 90 triangle because our equilateral triangle had all 60-degree angles, right? So this is 60. That one before we bisected it was 60 and 60. So by cutting this one into a 30, that forced us to have a perpendicular here. So technically when we make a 30, 60, 90 triangle, we're actually making 2 30, 60, 90 triangles, okay? We only need 1. But you have to make 2 to get just 1. All right? So that's creating a 30, 60, 90 triangle. Okay, so the final construction of a triangle that we're going to talk about for today is constructing a 45, 45, 90. All right. Just like all of our other triangle constructions, we're going to start with a work line. Okay, go ahead and get that drawn and choose a point with which you want to begin your work. All right. Actually, this one you want your point to be more in the center-ish. Okay. Because the first thing we need to do is to construct a perpendicular to this line at whatever starting point you chose, okay? Just like with all our other perpendiculars, we need to draw our little dog ears, I keep calling them, okay? So with our compass at a reasonably small but usable distance, we're going to start at the point that you chose and just make a little dog ear on one side, turning your compass without changing it, and dog ear the other side, okay? Now that we have those, we can extend our compass to whatever length you want. And working from both dog ears, I'm going to start here on the right. We're going to make a small arc at the top without changing your compass. Switch over to the other little dog ear and make an intersection, all right? That intersection point is now perpendicular to our original line, okay? And we just draw a nice long line going through it. All right, now we have 2 lines that are perpendicular to each other. You can see I didn't extend beyond our original work line because we don't really need to at this point. But we want it to be nice and straight going up. So here is our 90, right? We're 1/3 of the way there. Now to construct the 45 or the legs, I've given us here a distance that I want our legs to be. I'm pretty sure each problem in your homework will do the same. So we're going to measure the length here of my segment AB. That will be the legs of our 45, 45, 90. Okay, and it's about that length. Now, the example in the book, if you've looked at it, shows drawing an arc. If you want to, you can. I don't find it's necessary. What I'm going to do is put my pin at the vertex, and I'm going to mark where it crosses my vertical line, and then without changing it, I'm just going to turn it and mark where it crosses my horizontal line. Okay, you can make an arc there and make a quarter circle, but I don't know that it's necessarily necessary. All right, so we're going to put a point at each of those intersections, because we remember that in a 45, 45, 90, the legs are equal, right? Their legs are equal to each other. And so by connecting those equal legs, we have now drawn in our hypotenuse. And we've created successfully a 45, 45, 90 triangle. The final two constructions we're going to look at for this section are creating medians and altitudes. We're going to start with the medians right now. So if we need to remember that the median of a triangle is a segment whose endpoints are the vertex of an angle, okay, and the midpoint of the opposite side, right? That is the median of a triangle, the vertex of one angle and the midpoint of the opposite side. Okay, so that being said, we want to start here by finding the midpoint of AB. So just like any other midpoint, we want to set our compass to a length that's larger than the midpoint would be, okay? And then starting at one vertex, I'm going to start at B. We make an arc at the top and the bottom, okay? Then without changing your compass, switch over to your other endpoint or vertex. I'm going to go to A now and make my marks. So connecting these two X's here will give us the midpoint of B. Now, just like before, I don't want a full line. I'm just going to draw the line section that we need, which is where it actually intersects AB, okay? That point, M, is the midpoint between A and B. So to draw in the median, all we do is put our pencil at the vertex C and then draw a line to that midpoint. And you've successfully created a median, all right? So let's do it again. Except this time, we want our midpoint from, or our median, excuse me, from C, again, to AB, but our triangle's a little skewed differently. But the process is still the same. We need to find the midpoint of AB. So with our compass, mine's a bit too big here, larger than what the midpoint would be, I'm going to start with my pin at A and make a couple of very uncomfortable arcs, okay? And then I'm going to switch my pin over to B, and I'm going to make a couple more. All right? So just like before, even though we're at a different angle, right, we've got our two X's. So if we match these up here, we can draw the midpoint of AB, just like that. Then to get the median, we could start with our pencil at the vertex, and we draw a line to the midpoint. And that, my friends, is finding the median of a triangle. Now remember that every triangle has 3 medians. I'm pretty sure one of these homework problems is going to have you find all of them in one triangle. That can be kind of sloppy. So when you're measuring out your midpoints, I see how lightly I did it. I just kind of lightly drew them on there. But however you need to do it is fine. Use a different colored pencil lead. I know those exist nowadays, but however you can do it, that's easiest for you to do it. But remember that each triangle has 3 midpoint or medians, okay? There is a median from A to BC. There is a median from B to AC. It's just how it works, okay? And those are medians. Last but not least, we're going to look at altitudes, all right? Remember that an altitude of a triangle is a segment from a vertex, okay, perpendicular to the opposite side. Where the median was at the midpoint, right? The altitude is perpendicular. It does not care about the midpoint. It is perpendicular, all right? So we're going to find the altitude from C to AB. Okay, to do that, we need to set our compass at a radius larger than what it would be to get to AB. Okay, see how I'm just slightly longer? All right, with my pin at C, then I'm going to draw an arc. Now, see how I just barely crossed the line here? You can always extend line AB wherever you need it to be to work with it, okay? Don't be hesitant to do that. Auxiliary lines, right? You can just extend that line out so you have something to work with. But we just happen to hit right there, so we'll just leave it, okay? So now that we've got that, we can shrink our compass down to a usable size here. About maybe that length. We want it to be longer than what the middle of this would be. And using the intersection points of the arc that we drew, where it intersects AB, I'm going to start here on the right, and then I'm going to make an arc down there somewhere. Then I'm going to come back here, where it crosses here, this intersection, and I'm going to make an arc there as well. Okay, they cross here. If I come up to C and I line up with that intersection point that we made, I can draw a line down. I don't need to go all the way down to that intersection point, but that line is going to be perpendicular to AB. And there we have drawn an altitude from C to AB. Now, just like I talked about with the medians, each triangle has 3 altitudes. Heaven help you if you have to put all the medians and the altitudes in one triangle. That's going to be a lot of work and probably pretty messy, but I'm sure they will have you draw out all the altitudes. So again, there's an altitude from B to AC. There's an altitude from A to CB, okay? And they all have one. I want to do one more example of altitudes with you though, because not all altitudes fall inside of the triangle, all right? So I have a triangle here that just visually, there's no way from what's drawn here for you to draw a perpendicular line from C that crosses this AB, right? The inside of this triangle. It's just not going to happen. So like I said before, if you need to draw or extend lines, feel free to do that, okay? So I'm going to start this one by extending AB off to the side, all right? Then I'm going to follow the exact same steps I did on the first one. I'm going to make my compass longer than, it doesn't need that long, longer than it needs to be to cross the line, okay? Then with my pin at C, I'm going to draw my swoop or my arc, okay? And I need the 2 points of intersection, all right? Then I can shrink my compass down a bit. Don't have to, but you can. And then at each of the intersection points, I'm going to put my pin and draw an arc. So I'm going to do one from that side, put my pin here, and do one from that side. Now I've got my X, right? Marks a spot. So with my pencil at C and lining it up with the X down here, I can draw a line. And that's my perpendicular, okay? Yes, it falls outside of the triangle, but that is the altitude from C to AB, okay? It does not fall inside of the circle, but that is what it is. Sometimes it doesn't work out with these obtuse triangles. It's not going to work out inside the circle. Now, if we found the altitude of A to CB, that would fall inside the circle. And the altitude of B probably wouldn't fall inside the circle, okay? We would have to extend CA out to find the altitude of B, from B to CA. So not all triangles will have the altitudes within the circle, but that is how you construct an altitude.